inside the browser, which is these two text boxes. So now I configure my attack tool. I perform first the man in the browser attack, so now we have the devil inside the browser. And I do the configuration here, tell him what to steal. So it was email and password. Do a little update. User. Did you see anything happening here? Well, I pressed the login, and then you might notice this, the Word file on the desktop. This would probably not have gone to the desktop. This would have gone to some server, I don't know, in the US or in Russia. So let's see what our manual browser now did. So he just grabbed the content of those two fields when it was sent to the server. And email had the content of user, password box had the content of secret. So we just saw leakage of sensitive information. One consequence of a manual browser attack. So, well, you might not be very impressed about this, and maybe you remember that I promised in the beginning that we should also see how to improve the economy of you and your better path. So this is what we come to now. So here my wife has entered her online bank, and she's about to do a money transfer. I just didn't do the initial steps. Maybe there's some authentication in front here, some one-time passwords, something. Well, typically the man in the browser doesn't care about this. So he waits until that is done, and then he starts fooling around. In this case, it's my man in the browser. So it's an attack tool that I developed to help improve my economy a little bit. So my wife, she's spending quite a lot of money, transferring money to here and there. So I made this tool to divert some of this money back to my account. So it doesn't end up in some strange places and she don't overspend. So again, first I gain access to the browser. My wife is doing some money transfer. Let's say it's an easy account 123 123. This is the account number. So now I configure the man in the browser and say that, okay, whenever you see the account number 123 123 on the client side, please change it and modify it and send something different, namely my account number, to the server side. 666 666. I update, and my wife, she will not notice this. She will confirm and do the transaction. So what happened now? Okay, the man in the browser, he hooked up inside. When he saw the account number 123 123, which my wife typed, he changed it to my account number 666 666. So as you can see here, can you see it in the back? It's 666 666. It's my account number. Great. So now I receive the money my wife transferred, which is a good thing. The bad thing is that she will notice this, and when she does, I will be in trouble. So we have to do something about it. This will not work out. This will be very short pleasure for me. my wife will start screaming, and I will have a very tough day, if not month. So we need to do something in addition, which is, of course, what the standard manual browser does. So we can be more clever than this. So what I now do is that I say to the man in the browser, the devil in the browser, whenever you see the number 666 coming from the server side, change it back to the number what my wife typed. So I do this, I update. And now you see something changed. So when now we look at the transaction, the number is actually 123123, which was exactly what my wife typed. So now she will believe that everything is okay. Great. But on the server side, well, we have the number, my account number, 66666. So the money will go to me and my wife will not notice. Pretty good. And this is exactly what bank Trojans like SUSE are doing today. Staying in the middle like this, manipulating stuff without the end user being able to tell. And this is of course not only online banking. I mean, with the trend we have, cloud computing, software as a service, there's a lot of threat scenarios where this is highly relevant. Having your manual browser while you are doing something in your online CRM system is something you maybe should think about. Okay. So let's have a look at another example here. So now you might think that, oh, maybe I could add something to the browser, change the Internet Explorer executable a little bit, put in some security checks, see what's inside the browser. Well, you can, and if you do, you should be aware that starting a process like Internet Explorer is really a long process. So you would see the stack of the process being defined, the heap. You have loading of different central operating system modules. And then you also have loading of some initial modules, which on Windows are called app init. So now let's have a look at another very popular injection vector. I just registered the app init. And you see, again, I have my devil inside. So the result was the same, but the attack vector was now different. So what happened now is that before Notepad actually started executing, before execution entered notepad.exe, the devil was actually already active inside, because these app init modules are loaded at a very early stage. So for those of you who know Windows, this would be after NTDLL has been initialized, user 32, kernel 32 loading, and then this would be more or less the next thing happening. So app init, the devil DLLs would be there doing their stuff at a very early stage. Then the notepad DLLs would start to be loaded. Later on, execution would enter notepad.exe. And the devil had been there all the time. So this was different ways of gaining access to the browser. So we have our devil. But before we finish, let's just have a last look at a very easy and convenient way to manipulate the content of something handled by the browser. So here we have the username password box. I type something here. This is secret. And now I use the WinSpy attack tool to steal the content. So here you would see this is secret. So what happened now is again an exploit of the interface of the browser. So the attack tool sent a message to the text box, a get text message, and the text box happily replying back, well, here it is. So this is the secret, that string traveling back to the attack tool. Also by misusing this interface, I can set the value, which I will do now. So I would say no. This was not a secret. And now, when I hit enter, you see that it was not a secret. Again, it was a message. This time it was a set text traveling from this little attack tool to the text box saying, well, can you please change your content? The text box happily did so. One last thing that I would like to just mention shortly when it comes to ways of gaining access to the browser would of course be a debugger, a little bit on the meta level, but still very relevant when it comes to looking inside what's going on. So here I have the Ollie debugger. And now you can see the infection is really. It's in here. I try to attach it. But for most of you, this will not really be a surprise. So the debugger test, and you can see it stopped the browser and got access. So this is somewhat different threat when it comes to browser security. It's another way in, and the Ollie debugger is particularly interesting because, as you know, there might be anti-debuggers out there, and the Ollie debugger is really, for the bad guys, a very nice tool, because it has a lot of nice extensions like anti-debuggers, which you can use to fool anti-debuggers which may be present in the program. So for playing around with debugging and anti-debugging, Ollie debugger is very nice. So, to sum up, what did we learn today? Well, we saw different attack vectors on the browser, how interfaces could be exploited. I also gave you some hints about improving your own economy by transferring money a little bit from your wife to yourself. So, actually it was a lot of bad news in terms of security. Some good news about money flowing to you, but bad news about the security. So when it comes to this client side, things seems to be in a pretty bad shape. Here I'm not allowed to share the good news. The good news is that you can do something about it. There are different ways